Okay, page 2 of the Unit 2 study guide. Number 7. Which scenarios have a unit rate of 12 laps per hour? So it's something that I notice here. It says which scenarios. All right. So that means it's probably going to be more than one. But let's make sure. Okay, so my unit rate is 12 laps per hour. So that's 12 to 1. Okay. So let's look at A. Our initial rate is 12 to 1, so I need to compare what they give. All right, so let's set that equal to the 2 laps in 24 hours. And remember, whatever's done to one side, one part of the ratio has to be done to the other. It's going from 1 to 24 by multiplying by 24. So up here, that must mean I must also multiply by 24. And 12 times 24 is not 2. So A is not correct. Let's look at B. Let's see if this is equivalent. Our rate is 12 to 1, and we're going to set that equal to the 24 laps in 2 hours. All right, so remember, whatever we do to one part, we must do to the other. 1 going to 2 is times 2. So that means up here we need to also multiply by 2. And 12 times 2 is indeed 24. So B is one of our options. But remember, set scenarios, so there could be another one. Let's keep going. C, our original rate is 12 to 1. Let's compare that to their 60 laps in 4 hours. Okay, so I'm going from 1 to 4 by multiplying by 4. So that means up here I must go and also multiply by 4. And 12 times 4 is 48, not 60. So C is not correct. Now I could say, oh yeah, that automatically means D, but I need to make sure mathematically that it's correct. So I have my 12 to 1, and I'm setting that equal to 144 to 12. Alright, so going from 1 to 12 is being multiplied by 12. So that must mean up here also have to multiply by 12. And 12 times 12 is indeed 144. So my answers are B and D. Number 8. Juan's cookie recipe calls for 2 teaspoons of vanilla for every 8 teaspoons of sugar. What is the unit rate in terms of sugar to vanilla? This one causes you to pay attention because in the problem it tells you teaspoons of vanilla, then sugar. But the problem wants you, the answer, it has to be sugar to vanilla. So let's go ahead and first write what our sugar to vanilla is. So 8 teaspoons of sugar to 2 teaspoons of vanilla. So our initial ratio is 8 to 2. So if I know that I can get 8 teaspoons of sugar for 2 teaspoons of vanilla, I want to know how many teaspoons of sugar can I get for 1 teaspoon of vanilla. Because remember, we're trying to find the unit rate. Okay, so let's look at this. I'm going to first point my arrow to what I don't know and point my second one in the same direction. I'm going from 2 down to 1 by dividing by 2. So up here I need to also divide by 2. And 8 divided by 2 is 4. So my final ratio is, for my unit rate, is 4 teaspoons of sugar per teaspoon of vanilla. All right. Let's look at number 9. The table shows how much money a grocery store receives for selling different amounts of asparagus. If the unit rate is constant, what are the total sales for 10 pounds of asparagus? Okay. So first I need to find what is the rate. So I'm looking for 1 of something. I know how much 4 pounds of asparagus costs. I want to know how much 1 pound of asparagus costs. So that means that I'm going to set up my unit rate here. Remember, 1 for unit rate. And I'm trying to find out 1 pound. Okay. So I'm going to compare that. I'm going to use this first part of the table. I'm going to compare that to the 4 pounds for $6. Okay. So when I'm looking at this, I'm going from 4 to 1 by dividing by 4. So that means up here I need to also divide by 4. And when I pop it into the calculator, 6 divided by 4, I get 1.5. So that means it is $1.50. So that means it's $1.50 per pound of asparagus. So now I know for 1 pound is $1.50, and I need to multiply that by 10 pounds. So here I am, 1.5 times 10 gives me 15. So 10 pounds of asparagus costs $15. Number 10, look at the graph. Which statement is true about the relationship on the graph? All right, so I see, and you may find this hard to see, it's 1 to 12, 2 to 24, 3 to 36. So I'm going to go ahead and make this into a ratio table for my X and my Y's. So for 1 cartridge, it costs $12. When I wanted 2 cartridges, it costs $24. And according to the graph, 3 cartridges cost $36. All right, so I need to look at these. It says which statement is true about the relationship on the graph. So A says for every ink cartridge, the cost increases by $4. Well, let's look at our table or even our graph. When I'm going from 1 to 2 cartridges, is my money going from just 12 up $4 more? No, it's going up to 24. So A is wrong. Let's look at B. For every ink cartridge, the cost increases by $12. Let's see, going from 1 to 2 ink cartridges, it costs $12 and goes up to 24. Yeah, I would say that is indeed going up, increasing by $12. But let's just make sure the rest of these are not true, okay? For every ink cartridge, the cost decreases by $4. Well, we already know that it's true that it increases by 12 because I'm going from 12 to $24. All right, so we know that C is wrong. Let's look at D. For every ink cartridge, the cost decreases by 12. Well, no, when I go from 1 to 2 cartridges, that price is going up. So D is wrong. So we know that B is what's true about the relationship with the points on the graph. Let's look at number 11. A recipe for punch calls for 1 cup of sugar for every 6 cups of water. Which ordered pair would not be on a graph that describes this situation? So, this is all about equivalent ratios, okay? But we are going to, it's asking, remember how in this graph here, we had a table of equivalent ratios? 1 going to 2 times 2, 12 going to 24 times 2. 1 going to 3 is times 3, 12 going to 36 is times 3. So it's saying that these points are all equivalent ratios. So let's look at number 11. We have to see if these different points are going to be equivalent to this initial ratio they give us of 1 cup of sugar for every 6 cups of water. All right, 1 cup of sugar for every 6 cups of water. So that can be written as a point on the graph as 1,6. So let's look at A. A is 1,6. So it says which pair would not be on the graph. Well, 1,6, we see that it would be. So that's not the answer. Let's look at B, 3 comma 18. So in order to compare this, I have to set up to see if they are equivalent. So 1 comma 6, I have to find out if it's equivalent to 3 comma 18. So going from 1 to 3 is times 3. That means going from 6 to 18 is times 3. So nope, this is equivalent to. So this will be on a graph, and it's asking us for the point that's not on the graph. Let's look at C. We are comparing it to 1 comma 6, and we are going to see if 2 comma 30 is equivalent to this one. So I'm going from 1 to 2 by multiplying by 2. That means I have to also multiply by 2 on this side, and 6 times 2 is not 30. So it's looking like C is one that would not be on a graph. It's not equivalent to our initial point of 1 comma 6. Let's check D just to be sure. All right, so our original point is 1 comma 6, and I want to see if 4 comma 24 matches that, if it's equivalent. I'm going from 1 down to 4 by multiplying by 4. So that means over here I must also multiply by 4, and 6 times 4 is indeed 24. So this will be on the graph too. So the one that is not equivalent is 2 comma 30.